So good morning friends. In the last lecture, we have seen about the course outcomes and the syllabus of our subject. Now today, we will start with our first chapter, that is structures of material. Now in this particular topic, it is very interesting. First I will try to explain the contents in this particular lecture. So today we will try to cover the crystal structures, the crystal structure and Bravais lattice pattern, and the basics of atomic factor. Now first you just try to understand what is the crystal structure, and before that what is the importance. Now the various properties of the material are related with the structures. Now whatever may be the property it is required to perform during the real application, we are finding out the different properties, that is the physical property, chemical property, etc. And basically it is related with the structure. Now what is the structure? The structure are of many types such as crystal structure, microstructure, microscopic structure. All these affect the property of metal and alloy, and hence it is necessary to study these particular structures. Now these are the various structure, that is the crystal structure, macrostructure or microstructure. So all these structures are affecting on properties of material, and these properties we are dealing with the real application. So to study these structures are very important aspect. Now in this particular chapter, the crystal structures and the related terms are described, and the study of crystal structure is usually done by X-ray and electron microscopy. So these are the two aspects to study the crystal structure. The study of the microstructure is done by unaided eyes or by using low magnifications, usually below 10 linear magnification, and the study of microstructure is done by optical or electron microscope using much higher magnifications. So how that study has been carried out? Just to study the crystal structure, we are required X-ray and electron microscopy. Then to study macrostructure, we are required the low magnification, that is below the 10x, and to study the microstructure we are required the optical or electron microscopes. Now first of all, what is crystal structure? That we will start. This is the contents which are included in your university examinations. So just to understand particular concept, then we will just go with the different kind of the structures. Now the crystal structure deals with the atomic arrangement in the solids. So any component in the chemistry, you have just seen about this particular atom structure and all. So this crystal structure basically deals with the atomic arrangements in the solid. They are regular three-dimensional patterns of atoms in the space. Three-dimensional in the sense X, Y and Z. So these are the three directions are there. So all these particular structures are related with this three directional pattern, that is the X, Y and Z. So all these are perpendicular to each other. This regularity in the atomic arrangement in the solid comes due to the geometrical conditions which are imposed by the directional bonding or close packing of atoms. Now when we can be able to say it is the stable arrangement, that is the most stable arrangement of atoms in a crystal will be that the arrangement which minimizes the energy per volume. So when the energy per volume is minimized, we can say it is the most stable arrangement of the atoms in a crystal. Now this is the example, that is in the other way, what is the minimum energy means? That is to preserve the electrical neutrality, to satisfy the directionality and discreteness of all covalent bonds, minimize the strong ion-ion repulsions, packs the atoms as close as possible. So these are the four conditions when we can say the energy per unit volume is minimized and the crystal is stable. So these are the four conditions, that is preserve the electrical neutrality. It should be preserve the electric neutrality in the atoms, then satisfy the directionality and discreteness of covalent bond, that is, the direction should be proper, then minimize the strong ion-ion repulations and packs the atoms as close as possible. So whatever the atom arrangement it is there, it should be very closely packed. So we can say it will be a very stable arrangement of atoms. Now, next, the crystal structure observed in a solid are described in terms of idealized geometrical concept called as a space lattice. That is the what is the meaning of idealized geometrical concept? So that when idealized geometrical concept, it is called as a space lattice. The space lattice is a three-dimensional pattern of points in the space. So, what is the meaning of space lattice? You just try to imagine that in the space when we are having the three-dimensional pattern. Now you are imagining the space. So in that particular space, when the three-dimensional pattern it is there, three-dimensional in the sense I have explained already, it is the x, y and z direction. So the three-dimensional pattern of points in the space, it is called as a space lattice. So this is also called as a point lattice. So space lattice or point lattice, it is similar, and it is shown in figure. In the next figure, I will explain that the points in the space lattice with the identical surroundings are called as a lattice point. So when the points in the space lattice with some identical surroundings means every point are having the same kind of that surrounding. When it is there, it is called as a lattice point. So this is here you can be able to imagine. So in the space, the three-dimensional structure. So it will be a x, then y, and this will be its head. Okay, so these are the three. Now here you may see that you may say that, sir, it is going in this direction also and in this direction also, but it is the x direction, either positive or negative, but the direction is same. Okay, so it is horizontal. If it is vertical, then again it will be a perpendicular to these two conditions. So x, y and z direction. So these are the three-dimensional pattern. Okay, so here you can be able to see that this will be the x, then this will be the suppose y, and vertically it will be a z. So these are the three-dimensional pattern. Okay, so here the crystal structure it is there in space lattice. The every point when it is having the identical surrounding. Suppose this will be a point, and if you can be able to see the surrounding, it is too much identical with compared to this particular point. This particular point is also having the much similar kind of that surrounding. So this particular things are called as an lattice points. Okay, the points in the space lattice with the identical surroundings are called as an lattice points. So here this is the unit cell. Now we will just again the see. Here you can be able to see the some sort of that 3D image we can say of this particular crystal. So these are the points, these are the identical surroundings. So this will be a space. So in that particular space, these points are there with a three-dimensional pattern. Okay, so three-dimensional in the sense x, y, and z. So this will be a structure basically. So this is the once again we will see the space lattice. What is it means in the space? The three-dimensional patterns of points, it is also called as a point lattice. Okay, so this will be from this particular image you can be able to imagine. So that's why I've just taken the very black background over here, so you can be able to imagine this will be a space, this is the point, okay, which are having the three-dimensional pattern. So it is called as a point lattice or space lattice. Now this might be clear to you. Now what is the meaning of lattice points? So when this points in this place lattice with an identical surrounding. So here you can be able to clear those things. This will be suppose a point in the space lattice with an identical surrounding. So basically all those points are basically having the identical kind of that surroundings, because it is the just some sort of that rectangle. So every point is almost having the identical surrounding. So this will be a lattice points. Now, what is the meaning of unit cell? Now, unit cell are described by the three factors A, B, C drawn from one corner of the cell. Now, here just see unit cell, which is having the three vectors A, B and C drawn from one corner of the cell. Now this is the unit cell. Okay, this is the A, this is the B and this is the C with a single point. It has been drawn. Okay, so this is called as a unit cell. Then what is the condition? Again, these vectors define the cell and are called crystallography axis of the cell. So these vectors should be define the cell. That particular cell, it has to be defined by that particular vector. Okay, then they may also describe in terms of their lengths A, B, C. So whatever may be the A, B, C, it has been shown. Okay, it might be a length and the angles between them, that is the alpha, beta and gamma. So here you can be able to say this will be the length. Suppose what is the it has been shown. So you may consider this as a length of that particular cell. So from this one point it has been drawn A, so this will be a length A, then this will be a length B, then this will be the length C and the angle between them is alpha. Okay, then beta and third one is the gamma. So alpha angle, it is in between the length C and B, beta angle, it is in between the length C and length A, and gamma angle, it will be in the length of A and B. Okay, so these lengths and angles are lattice constant or lattice parameter of the unit cell. So whatever may be this length and angle, it has been shown. It is either called as a lattice constant or lattice parameter. So these terms might be quite, you are feeling some sort of the difficulty to understand, but frequently when we are going with this particular concepts, so you can be able to thoroughly understand those things. So you just try to right now understand this particular part. Then we will take the example, that is the lattice. Okay, the square with the chosen primitives, translational vectors, that is u1 ax and u2 ay, that is u1 and u2 are the integer. So those are lattice mathematical mesh of the points on the space and the basis. So basically unit cell. Now this is just for the purpose of the understanding what is the meaning of unit cell. Unit cell, it is just a summation or combination of lattice and the basis. So what is the meaning of lattice and what is the meaning of basis? Here in the next diagram we will try to cover it. Okay, so basis, it is the blue circle located at x 0 0. So here you can be able to see these are the blue circles. So this is the blue circles located at 0 0 plus yellow oval located at a by 2 and a by 2. So basically square with the chosen primitive translational vector u1 a x. So u1 a x means in this particular direction units with a x direction and units with a y direction. Okay, so here only it has been explained. So u1 and u2, it is the integer. So u1 a x and u2 a y. So lattice, here it will be cleared, u1 a x direction and u2 a y direction. So this will be the lattice points and the basis. What is the meaning of basis? So blue circles located at 0 0 plus yellow ovals located at a by 2 a by 2. The basis coordinators are found by the identical repeating unit cell, setting one corner of the cell as 0 0 and finding the fractional coordinator of the other atoms. So here you can be able to see. So what is the meaning of this particular basis? So this will be a coordinator. Suppose imagine it will be around situated at 0 0. Okay, this will be a, and the yellow circles, it will be a distance of a by 2, means half of this particular distance. So these are the yellow circles. So again when you will move to this particular point, imagine it will be a, suppose on a distance a0, likewise that distance will be there. So these will be the structure will be called as a basis and the directional it will be called as a lattice. Now what is the meaning of unit cell? This will be a unit cell. So that is when we are adding the basis and lattice, the unit cell formation will be there. So unit cell, that is the lattice plus basis repeating units in the crystal. Last lecture we have discussed this primitive cell, which in the properties of the lattice. So this is the mathematical just construction of this particular part. Now lattice points can be arranged in 14 different arrangements or arrays called as a Brevis lattice. So what are the different 14? This is the lattice points. Already we have seen that particular concept. So the 14 different arrangements for that particular Brevis lattice, it is there, and the actual crystal structures will be similar to this 14 previous lattice and can be obtained by assuming the atoms or group of atoms at the position of lattice points. So this is the 14 basic structures are there. First it is called as a truncating. So in this only the simple pattern it is there of parameters. Then monoclinic. So in that monoclinic, simple and volume centered parameters are there. So again in the orthorhombic, again the four constructions are there with the simple, then volume centered. Now what is the meaning of volume centered? And you just try to understand. So here you can be able to see the 4 points 1, 2, 3, 4. Again 1, 2, 3, 4. It is situated at the corner. So only it is called a simple points. Now in this particular figure, again these 4 patterns or that 4 points are situated at the corners, and again in this volume centered one more point it is there which is situated at the center of this particular rectangle. So that's why it is called a volume centered. Then base centered. Now here in the orthorhombic structure, simple, then volume centered and base centered. Base centered in the sense here two more points you can be able to see. So on the base, either it will be a base, or if you reverse this particular part, this will be a base. So on that particular base, you may see in these two particular units. And face centered. So in the face center, on every face, so 1, 4 plus 2 faces means 6 faces are there. So 1, 2, 3, 4, 5 and 6. 6 points. Apart from the corner points, here you can be able to see the 6 points. 1, 2, 3, 4, 5 and 6. So this is the face centered. So might be it has been cleared. So in the orthorhombic structure, all the 4 structures are there: simple, volume centered, base centered and face centered. Now in the tetragonal, here simple structure it will be there and volume centered. So here one more point it will be there. So that's why it is in the volume center. Now in the trigonal, again the simple. So 4 corners and 4 more corners. Then in the cubic structure, here in the cubic structure, simple, volume centered and face center. There will be no any base center. So because all 4 corners might be where we can be able to consider as a base. So in the hexagonal, it is again the simple structure. So here these are not the 2 points, only 6 points at this particular corner and 6 points at this particular edge, that is at the corner edges. So this will be only the 14 previous lattice patterns. So only you just understand this thing. That's why it has been explained. So in the triclinic, only one structure. In the monoclinic, 2 structures are there, simple and volume centered. In the orthorhombic, 4 structures are there, simple, volume centered, base centered and face centered. In the tetragonal, 2 structures are there, simple and volume centered. In the trigonal, 1 structure it is there. In the cubic, 3 structures are there, simple, volume centered and face centered. And hexagonal, only 1, that is simple. So in the Brevis Lateran pattern, I explained that the 14 structures are there. What are those 14 structures? 1, then this 2 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So these are the 14 structures which is called a Brevis lattice. So these are the only patterns. So later on when we will go for the atomic number calculation or atomic packing factor calculation, so average number of atoms per unit cell that we need to find out, and later on we need to calculate the atomic packing factors. So those particular things we should or you should required this particular structures. So in this lattice points, okay, so that 14 arrangements might be you have got thoroughly, which are the 14 points are there. So later on also you can be able to see these things. So up to the today's lecture, this particular part, which is very important as a basic part. So in the latter lectures, you should understand the further concept, how to calculate the atomic packing factor, as well as how to calculate the average number of atoms per unit cell. So you just watch this particular lecture 2 to 3 times, so you can be able to understand the further concepts. So today's lecture it is sufficient. So just once again, thank you very much for the patience listening. And in the next lecture, we will just start with the average number of atoms per unit cell. Thank you.